Are you struggling with figuring out the right GPU resource for fine-tuning a large language model? Finding it difficult to set up a compatible GPU computing environment for your fine-tuning process, or struggling with many Python libraries that needs to be integrated? Not to worry anymore. MonsterAPI's no-code large language model fine-tuning portal takes care of all the complexities for you and allows you to launch a fine-tuning job in a matter of minutes without writing a single line of code. If you have a custom private dataset that you want to fine-tune, no problem. Monster's fine-tuning portal will accept any custom dataset for your custom fine-tuning of a model. And then after fine-tuning, you can deploy your custom LLMs as API endpoints using Monster Deploy. The REST API endpoint can then be integrated into any public web or mobile application. Now, no-code fine-tuning is a breakthrough in the open source world, as it makes fine-tuning 10x more accessible to everyone. And MonsterAPI supports 3 key techniques that make the platform even much better compared to many of its competitors. And these includes QLoRA with 4-bit quantization and NF4. This feature reduces the size of the model by compressing them using quantization technique. This allows users to fine-tune larger models using less memory and bandwidth. I will discuss it in slightly more detail in a second, but first just go over another 2 key points that MonsterAPI has and which are of hugely importance when you are fine-tuning. So the next one is Flash Attention 2. This feature improves the speed and efficiency of training by using a novel attention mechanism that reduces the computational complexity of the models. And the third one is data and model parallelism on multiple GPUs. This feature enables users to train bigger models using larger context lengths by distributing the data and the model across multiple GPUs. Alright, here is a quick snapshot of fine-tuning with MonsterAPI's no-code portal versus AWS and Replicate, which is another provider. Now, for the preparation, for AWS, you need to set up the AWS account, install CLI, SDKs, and understand the billing, and sometimes it's a huge process. You really have to go through all the hassles here. And for Replicate as well, you have to sign up, review documentation, etc. And with Monster, sign up, it's a no-code approach, very simple setup. Then compute resources, select from for AWS, you need to select from a wide range of EC2 instances based on needs. And you really need to have a little bit of idea about these EC2 instances, launching and closing them, else you can really incur a lot of cost unless you are very careful. With Replicate, it's limited by Replicate's offering less control over specific resources. It is slightly more simpler than AWS. But with MonsterAPI, it's the simplest and the fastest because it's a decentralized GPU network and optimized for memory usage. And you really don't have to set up many things here at all. And with the MonsterAPI, there's also advantages for linking your datasets, because here with Monster, you can directly link the Hugging Face datasets. And there's a drop-down indeed, where all the main and famous Hugging Face datasets are directly there. You can just select it. And if you are uploading your own custom dataset, you can just upload it directly in the portal before launching your fine-tuning job. And of course, with AWS, you have to use S3 and you need to know the S3 configuration, etc. And Replicate also is dependent on its own storage solution or external storage. And then continuing on this line, MonsterAPI's development environment is much more simplified. It's very user-friendly and very easy to set up. We will see that in a minute. And it has all the predefined tasks versus AWS's SageMaker, which of course is very comprehensive, but it has a lot more complexities. And then in the fine-tuning, again, fine-tuning is very simple. You just need to set up the configuration, which we'll see in a minute, and it supports, MonsterAPI supports all the latest technologies like QLoRA, Flash Attention 2, and parallelization of your multi-GPU setup, etc. And for monitoring and optimization of your fine-tuning job, of course, SageMaker provides you lots of comprehensive tools, but your support from MonsterAPI is also great. You get performance monitoring through detailed logs, optimized algorithms for better performance. So overall, I think the three most excellent points about using Monster APIs are these: ease of use, speed, and affordability. So I would say Monster API almost democratizes the work of fine-tuning a large language models, because by many people it's still considered very complex, needs a lot of money and great compute resources. But with Monster API, because everything is taken care of for you, so you can very much just launch the fine-tuning within maximum 5 to 6 minutes. That's it. So if you are a user who is seeking simplicity, affordability, and efficiency, and without a lot of hassle, then this is the go-to tool for you. All right. Now, earlier I said that Monster API supports QLoRA or LoRA training. Now, to the background, over the past year, LoRA, that is low rank adaptation, has pretty much revolutionized fine-tuning, and almost every fine-tuning job in the industry is using some form of LoRA and QLoRA. So let's just quickly see why they have become so important. So the core idea behind LoRA is that original weight matrix W is adapted by adding a low rank product of two much smaller matrices. So when fine-tuning with LoRA, the original matrix W is frozen and only the elements of the low-rank matrices are trained, leading to a drastic reduction in the trainable parameters count. And QLoRA, that is quantized LoRA, further elevates this concept by introducing quantization into the mix. The mechanism here is about reducing the precision of the elements in weight matrices. So instead of using high precision floats like 32-bit floating point numbers, quantization represents these values with lower precision formats like 16-bit or 8-bit or even 4-bit. So the reduced precision means that each number takes up less memory. For instance, a 8-bit integer uses 4 times less memory than a 32-bit float number, leading to a hugely faster calculation and a huge savings in compute resources when fine-tuning. The genius of this approach is in striking a balance between efficiency and model performance. While quantization introduces some approximation error, the impact on model accuracy is typically minor, especially when fine-tuning on specific tasks where the adaptation scope is limited. And now with Monster API, you can completely use QLoRA and LoRA up to as low as 4-bit quantization precision, and again without writing any single line of code, because all you have to do to integrate quantization, that is QLoRA and LoRA, is just change some configuration when setting up your fine-tuning job. Alright, now we are going to do an actual fine-tuning using the Monster API's portal. So the first thing you do is sign up, and once sign up, you will get some credit, which is enough for you to do some basic experimentation with some of the models, that is the popular ones. And right now I'm looking at these Finetuning LLMs, this tab in their site, and it has got a lot of information. You should definitely go through them. And they have some great blogs written pretty recently with the latest information on the actual fine-tuning workflow, etc. And also do check out their pricing before you start actually hacking around, because you need to be aware that for each minute you fine-tune, there's a cost to that. So definitely go check out their pricing, which is actually very, very reasonable to my experience. And there I am in their fine-tuning portal. So this is the dashboard tab, and you can see that I have got a free credit of 2,500 here after signing up. And you just go to fine-tuning and create new job. I already have a default name given. Let's just check it. Test Mistral. Model name, you select whichever you prefer for your use case. And I can see that most of all the recent and popular models that are currently used in Hugging Face by the industry are all supported here. So I am going to choose a Mistral from here, the most well-known over the last couple of months. So I'm going to choose this one, Mistral-7b instruct version. It's a pretty large model of mixture of experts. So next step. All right, select a task. I am going to do instruction fine tuning, but depending on your situation, you may prefer to choose summary generator, text classification, mask modeling, etc. Yeah, so for my case currently, instruction fine tuning and dataset. Yeah, so here you can choose the ones that are coming directly from the Hugging Face. You can this is for experimentation purpose, unless of course this is what you are targeting. But then once you can actually upload your own dataset here. And for uploading, all you have to do is just click here, upload and use your own dataset. And there, just choose your dataset from your machine. And we can see that JSON, Paraquet, CSV, and JSON-L, all of these popular formats are supported here. But for this purpose, currently, I'm just going to use one of the default from Hugging Face. So here in the drop down, I'm just going to choose this one, Alpaca GPT-4. It's a very, very popular one and very well formatted. So for simplicity, I'm going to just use this. And remember that although you are seeing only this many here, but you can choose pretty much any popular Hugging Face dataset and just click on other. All right. And then here, just enter the entire dataset link, taking it from Hugging Face. And for choosing a subset, we can leave it at default, but validation split ratio. So by default, it's 10%, and you can increase it or decrease it. I'm just going to make it 15%. Okay. And yeah, so the dataset that I chose, Alpaca GPT-4, let's quickly have a look at that in Hugging Face. So this is the dataset that I'm talking about that's being pulled into MonsterAPI, but this is the original one. Currently, it is the Hugging Face page. So there's a train segment has 52,000 rows of data, and it's an instruction data set. That is, it will have an instruction column. And for the context, some of the rows will have input. That is like a context for the instruction. But this input is not all are filled up. And the output is the actual output from the LLM. That is, this is the answer from the large language model that is coming after the instruction. So coming back to our portal, there's an option to change the dataset format here. And this format is this part. Now, you can see that currently it is grayed out. I cannot change it. That's because I selected one of the default dataset. So for that, it's already formatted correctly because I selected the default one. But in case if you choose something else, you can change it here. For example, let's say I want to make this Alpaca GPT-4. But you can see that it already has this instruction and output column. But let's say if it was something else, all you have to do is take the column name, copy it, go to your portal, and replace it here. Like it says, replace with instruction column name. Now, whatever your instruction column, you can just put it like this. And similarly, you have to take this output column name, go back there and replace it here. And it says that replace with the response column name. So this is a response from the LLM like this. But in this particular case, I am choosing default one, Alpaca GPT-4. That's why it's grayed out because it has already taken whatever the output format and the instruction format. It is suited for this data set. All right, after I made my data set, just go to next step. And this is where you have to specify the number of epochs that you want to train for. As you can see, it has already by default taken some of the reasonable numbers. So three epochs is the default one it has taken. And I think that's pretty good for this situation. Context window 512, you can definitely change it to whatever you want. And early stopping patience, that also you can change. And learning rate 0.00020 is the default. And again, this one you can change. Okay. And these are your 1DB username, 1DB key, because you want your logging to be completely recorded in 1DB. So you can just put all these credentials here, project name, 1DB run name, etc. And for uploading the fine-tuned final model to Hugging Face, you can put your Hugging Face key and Hugging Face model path. So it's like the Those who are doing it with the actual Python code, it's like push to Hugging Face. There's a configuration if you are using the transformer model of Hugging Face, that is the Finetuned model, will be pushed to Hugging Face repository. So that's the equivalent here. So here there is no code, nothing absolutely at all. You just put your Hugging Face key and the model path, and everything else will be taken care of. All right, now next step, and this is where you set up. You do not support this value. Okay, obviously. So let's keep it at 512. And next step. Yep. Job configuration, advanced settings. Actually, before coming to this last step, let's go back because I forgot a very important part, which is that after selecting all this configuration, you can actually set all these advanced settings. So once you click on this advanced setting portion, you will see all these extra hyperparameters, which are super important for any serious fine-tuning job. So for example, you can select your LoRA R, that is a rank parameter. By default, I think it takes 8. 8 is a minimum number. That's the default number, and you can definitely increase it. And for the explanation, these R hyperparameter represent the rank of the low rank metrics learned during the fine-tuning process. So this rank parameter basically indicates how much information is packed into the metrics. So as this value is increased, that is the value of this R parameter is increased, the number of parameters needed to be updated or trained during the fine-tuning also increases. So higher value of this param will mean training will go on for a longer period of time, and a lower value of the R parameter will lead to a quicker, less computationally intensive training process, will be done much faster, but may affect the quality of the model thus produced. So that was the rank parameter. Then dropout. This is again a very vanilla parameter, and most of the fine-tuning job, depending on your data set and depending on your target, you may want to change it. And for the learning rate scheduler, I can see it supports quite a few of the popular ones. I mean, this is all the learning scheduler you will need. Most of them are supported here. By default, it takes reduce LR on plate. Of course, you can choose linear, cosine with restarts, polynomial, constant, etc. Fantastic. And then LoRA alpha, this is another hyperparameter. 16 is the minimum number and the default number, and you can change it. And then you can also set the gradient accumulation steps right here. And gradient accumulation is a technique primarily used when the batch size required for training a model is too large to fit into the GPU memory that you have. So instead of reducing the batch size, which might affect the training dynamics, for example, model might converge to a different local minima with smaller batch sizes, gradient accumulation accumulates the gradients over multiple mini batches and updates the model's weights less frequently. So this step determines after how many steps this accumulation should occur. And so this is again a hyperparameter, and you should experiment with different value of these while fine-tuning. And after you selected all of these, you are ready to go to the last step, which is the combined view of everything that you have set up for this job. And this is the job name, Mistral test model. You can see all the configurations right here. If you don't find something right, just go back and change. Epochs, gradient accumulation step, early stopping patience, etc., etc. And the most important thing is here. This is very important. You need to note it. That is the estimated cost here is 40 credit per minute. And I have a 2,500 free credit. That means this model I can train for around 62.5 minutes. Now, that may not be enough for this particular model because this is really a huge model. The actual file size is almost close to 48 to 49 GB. So if you are really trying to complete all the 3 epochs for this model, you may need more credit than this. But for this test, I'm just going to go with this, and that's what it says as well. To avoid service interruption and ensure your fine-tuning job runs to completion, when your credit balance is low, you may set up auto payment here. Yeah, so in that case, if you just set up the auto payment details here, no training will stop. It will just continue. Okay, now create a job, and it may take a few minutes to create the job. In the meantime, we'll quickly go through the documentation, because everything I just said till now about this is very well written and well organized in their official documentation. So right now I'm looking at their documentation under the guide section of MonsterAPI. So they have all these different section: introduction, then fine-tuning an LLM. This is what is important for us currently. So let's see what they say. Curated list of models we support for fine-tuning. As you can see, there are lots of models, and these are pretty much all the popular models currently in Hugging Face. And about the dataset preparation, they say this. You may also refer to our guide on our custom dataset for LLM fine-tuning. And maximum supported cutoff length for models. This is, they are talking about the context window. So models with less than 30 billion parameter 2048 is a max context window. This is a number of tokens, and models with more than 30B, it's 512. Remember, for our case, we just selected 512. And in the guide, one particular area I wanted to show you is this one. Use any other unlisted Hugging Face dataset, because in my case, we just use a default pre-built dataset, but they have complete flexibility here. That is, if you are unable to find a Hugging Face dataset of your choice in our curated list, then you may choose other option and provide dataset name for the Hugging Face dataset to fetch and use. Yeah. And also check out their custom dataset portion. So it enables you to upload your bespoke datasets directly to MonsterAPI platform, providing a seamless way to fine-tune LLMs on your specific dataset. And also they take care of your data very well. With data privacy as our utmost priority, this service ensures secure, confidential utilization of your personalized datasets. So yeah. That's very important. And also, once your job starts, that is, a fine-tuning job starts, you can check the complete status and tracking. And there's a guidance on that as well. So a job can have 4 states: launching, in progress, completed, failed. When a job is in progress, after launching, it typically takes 4 to 5 minutes for the job to enter the in progress state. That is, once you keep it ready and launch it, it will take this many minutes. And during this phase, you can view job logs by selecting view logs, etc. All right. And billing. Here is what jobs are billed based on the time they are in progress, typically consuming 40 to 55 credits per minute, ensuring your account has at least 500 credits and a valid payment method set to avoid job termination. Yep. So that means when you start a job, that is launch a job, and it shows this particular status, it will not consume any credit because it has not started yet. And you can check that by clicking here, and it will say Mistral test credit consumed 0. That means the starting status does not consume any credit. It will only consume credit once. Wait a second. Once it's in the in progress status, and that's they have mentioned it very clearly. All right, after waiting for around 8 minutes, I can just see that it's in progress. So this really huge model is actually getting trained, and it's consuming my credit in the in progress status. And let's see how long it goes. So that was the workflow of fine tuning, and I also quickly wanted to show you a deployment notebook, because like I mentioned earlier, that once you have your fine-tuned model, and then you can deploy your custom LLM, that is your fine-tuned LLM, as an API endpoint. And MonsterAPI will provide you a REST API endpoints, which can then be integrated into any public web or mobile application. And this collab notebook I got from Monster itself. They have actually given quite a few example notebook in their site, so you can actually visit this page projects using MonsterAPI, and there are so many examples for various situations, and for each of them there is a collab demo. So for each one you will have the complete code for you to run and deploy and see the effect. So let's very quickly go through this collab. It's only very few lines of code for actually deploying an API endpoint using MonsterAPI deployment service. So first, of course, you need your API key, and then you need to install these pip packages, MonsterAPI, and then bring in your relevant module from the MonsterAPI. So here, this particular line is just bringing in the MC client, which is coming from MonsterAPI package, because this MC client will manage your client-side code here. And to the MC client, you pass your API key. And this code is so simple. It's just basically you are defining few configuration. That is all. And once this deploy client is defined, you need to create an LLM deployment. And remember, this whole deployment is using this Mistral-7b model with LoRA adapter that was previously fine-tuned. And that's what it is serving, that this notebook is serving. So to create the LLM deployment, first you need to define your launch payload configuration. So that is your base model path, your LoRA model path, and then prompt template, API auth token per GPU VRAM, GPU count, etc. And then launch the deployment with this line, return deployment client, deploy client dot deploy. And then you pass your LLM and launch payload that you just defined. And that will give you a deployment ID. You can print that deployment ID. And then these are various deployment status. That is, for example, below mentioned are different types of status responses. So in progress, status pending, status failed, then building, and finally live. This is the most important one. That means everything is just live. And this status is for terminated user, because after your deployment time is over, you need to kill it by terminating the deployment. Okay, so once the deployment is live, let's query our deployed LLM endpoint. So this particular code is just for querying. So first you check with this assert line that the deployment status is live. And then service client is coming from MC client, base URL status return.get URL. And then here you defined your payload. Here the input variable, your prompt goes, write a Python script that reads from CSV file and output to JSON file. Okay. And then I get the output from the model with this line, service client.generate. And then I am doing this payload.getStream for I in outputs, print I0. And this is what it outputs. Let me see the output in more detail. Yeah, this is the output I get. It's defining the method right here. Okay, now one thing I wanted to point out is at the very top when I'm defining the base model path and the LoRA model path. So here the theory is that once you have fine-tuned an LLM on MonsterAPI, you will receive the adapter weights as the final output. This adapter contains your fine-tuned model's weights that Monster will host as an API endpoint using Monster Deploy. And Monster Deploy optimizes its, and that's the reason I am passing these base model path and the LoRA model path. So the LoRA model path is actually the adapter weight. This is a zip file. And Monster Deploy optimizes its backend operations using the VLLM library. VLLM currently is the most popular library for fast inferencing on a large language model, and it's especially notable for its state-of-the-art serving throughput. And so that was a quick deployment code here. And of course, the last line is for termination of the deployment, because once you are done using the deployed model, don't forget to terminate your deployment and thus avoid billing charges. So it's a single line of code right here, and your deployment client will be terminated. So that was a quick description of the deployment with Monster Deploy API, and definitely check out the documentation here. It's very well written. All right, that's a wrap for this video. Do check out their site, and I will put all the links in the description. And thank you very much for watching. See you in the next one.